Hello, you're welcome to the Math Classroom. If you are a subscriber, thank you so much for the support. If you are new on my channel, don't forget to subscribe, like, share the videos among your network as well. Your good comments are welcome in the comment section. In our lesson today, we are looking at eigenvalues and eigenvectors of a matrix. And we'll be looking at a 2 by 2 matrix today. So let's look at the definition of our eigenvalues and eigenvectors. So if I have a matrix A, that is a square matrix of order 2, then we are saying lambda is an eigenvalue if there exists a vector x such that Ax is equal to lambda x. What do I mean by that? We are saying if I have a matrix A, for each matrix, there is what? An eigenvalue and a vector x, which is called what? The eigenvector. So we are saying that x is the corresponding eigenvector. So for each lambda, which is the eigenvalue, there is a corresponding eigenvector, which is what? X. What does it mean to say that Ax is equal to lambda x? Let's look at this example. If I have a matrix 2, 2, 2, 2, that's a 2 by 2 matrix. This is 1, 1. If you multiply, you realize that you have what? 4, 4, which is equal to what? 4, let's say 1, 1. So if this was our A, so let's say if this is A, this is X, we are saying it is equal to, what do you have here? Lambda what? X. So you realize that you are saying what? Your lambda is a multiple of your vector X. It's a multiple of our vector what? X. So what do you notice? You notice that the vector I have, A, the matrix A, and the vector X, when you multiply, you are getting what? A multiple of the what? Initial what? Vector you had, which we are calling what? The eigen what? Vector. So from here, you realize that from here, I could express this as what? A x minus what? Lambda x, which is equal to what? 0. Then I can rewrite this as what? Ax minus I lambda x to be equal to what? 0. What is our I here? I here is what? Our identity what? Matrix. And for the identity matrix, if you multiply any identity matrix by another matrix, you still get what? the same thing. So that even if I multiply identity times what? Lambda, which is what? Lambda is always what? A scalar value. We are getting what? Our lambda back. So I can equally express this as A minus identity lambda. We factorize what? X out. X to be equal to what? 0. So this equation we have here is what we are calling the homogeneous system of equation. From here, so this is a homogeneous system of equation. From here, we are saying that x, which is our eigenvector, is not equal to what? 0, which implies that our x is a non-zero what? Zero factor. If x is a non-zero vector, then I can write A. So now I have what? What do I have? I have A minus what? I lambda to be equal to what? 0. So this implies that A lambda, that it's equal to what? 0. And because we are saying it is what? A homogeneous system of equation, it means that it has what? A non-trivial solution. If I take the determinants of this equation, the determinants of A minus what? I lambda to be equal to what? 0. If you take the determinants of this, so with this determinant, this expression will give us what? A polynomial equation. A polynomial equation or characteristic what? Equation, or your characteristic equation of degree n. Okay, so if I have a characteristic equation, so if my determinants of A minus I lambda it's equal to 0. If I have a characteristic equation, I can then find the roots. So I could find the roots of this characteristic equation. And the roots is what? Our eigenwords values. So the root is going to give us what? The eigenwords values. So in knowing the roots to be our eigenvalues, you can equally find what? Each corresponding what? Eigenvector for that. Let's take an example. Example here. We want to find the eigenvalue of the matrix A, which is equal to 3, 4, 2, and 1. How do I find the eigenvalues of what? This matrix. We are saying to find the eigenvalues, we know we have what? A minus what? I lambda to be equal to what? 0. What is our I? I is the identity matrix, which is what? 1, 0, 0, 1. Because our matrix here is what? Of order what? 2. So now let's look at this. If I want to solve for lambda I, you realize that I have what? Lambda 1, 0, 0, 1, which is going to be equal to what? Lambda 0, 0, what? Lambda. So this is what you have for lambda I. So I can solve for so let's look at A. So if I have A minus I lambda, let's solve for that. What is our A? A is what? 3, 4, 2, 1 minus I lambda, which is that. So I have lambda 0, 0, what? Lambda. If you find this, what do we get? So don't forget, I nearly forgot here, determinant of this is what is equal to 0. So let's solve. You have what? From here, 3 minus lambda, you have 4. Then I have what? 2. Then I have what? 1 minus what? Lambda. Okay, now let's find the determinant of this. We are saying that the determinant of A minus I lambda is equal to what? 0. So this implies that we take the determinant of our matrix, which we have done so in our previous lectures. If you've not watched our lectures on determinants, I encourage you to go and watch that video. It's equal to what? 0. So if you want to find our determinant, let's multiply. So you realize that from here, what do we have? You multiply this times that. So I have 3 minus lambda times 1 minus lambda minus this and that. So I have what? 2 and 4 to be equal to what? 0. If you multiply, what do you have? I have what? You realize this times this is 3 minus 3 lambda minus what? Lambda plus lambda squared, which is equal to what? 0. So what do I have here? You realize that we have what? Lambda squared. This and that is going to give us what? Minus 4 lambda. Then minus what? 8 here. So 3 minus what? 8 is what? Minus 5 to be equal to what? 0. So we find the roots of this quadratic equation. If you do so, you realize that if I expand, I have what? Lambda minus 5, then lambda plus 1 to be equal to what? 0. So what is lambda? Let's solve for lambda. So I have lambda minus 5, which is equal to 0. This implies that my lambda is equal to what? 5. Then lambda plus 1 equal to 0. This implies that my lambda is equal to minus what? 1. So I have been able to find the roots of the quadratic equation, which is what? My eigenvalues. So my eigenvalues here is going to be what? Lambda 1 is going to be equal to 5. Then lambda 2 is going to be equal to what? Minus 1. So these are the eigenvalues for the matrix A we had. With the eigenvalues, we could find the eigenvectors. But in this lecture, we are looking at the eigenvalues. Till our next lesson on more examples on eigenvalues, kindly stay safe and don't forget to subscribe.